Hello, this is a physics question under the topic capacitors and capacitance. Here we are given three capacitors connected in parallel and we are asked to calculate the effective capacitance of the circuit, the total charge stored by the capacitors and energy stored in the circuit. To effectively understand this, we need to first understand what we call capacitor. A capacitor is a device that stores electrical charges. It is made up of two parallel plates, just like we have it here, separated by a dielectric constant. Two parallel plates separated by a dielectric constant. So in electronics, we represent it with this symbol. Easily put, we can do this. When you have a circuit in which there are two plates opposite each other like this of equal length, this is a capacitor. Unlike the one we use for cell, the two plates are not of equal size. This is cell and this is a capacitor. Once again, a capacitor stores charges in an electric circuit. Now back to the question that asks us to do this. These are connected in parallel. Take note, in parallel. For parallel connection, it means we have it this way. This way. So they are connected. When they are connected in parallel, all their ends are joined together in one point. That is parallel connection. So here now they are connected to the source of 10 volts. 10 volts. So we can take this as 6 microfarad. This is 10 microfarad and this is 14 microfarad. So connected like this in parallel. When they are connected in parallel, effective capacitance means we are going to add all the capacitance here together. Unlike in resistor, when resistors are connected in parallel, it is 1 over the effective resistance equals to the sum of inverse of each of the resistors. But here, so to answer this, the effective capacitance, which we can say C effective, let's take note of that, that's the effective capacitance, is equals to the total sum of all the capacitance in the circuit, C1 plus C2 plus C3. So the C1 here is 6 microfarad plus 10 microfarad plus 14 microfarad. And when we add all this together, it gives us 30 microfarad. Remember, the microfarad can be expressed as 30 times 10 raised to power minus 6. That is microfarad. So this is the effective capacitance in that circuit. This is the effective capacitance in the circuit. The next question says the total charge stored by the capacitor. Total charge stored by the capacitor. The quantity of charge stored in a capacitor is given as the product of the effective capacitance and the voltage flowing through that circuit. Charge Q is equals to the product of effective capacitance and the voltage flowing through that circuit. So the effective capacitance here is 30 microfarad, which is 30 times 10 raised to the power minus 6 multiplied by the volt, which is 10. So if we do that, this is going to give us 300 times 10 raised to the power minus 6, which can be said to be 3 times 10 raised to the power minus 4. Because it's charge is measured in coulomb, so the SI unit is C, coulomb. Now that we know this, the last part is the energy stored in the circuit. Remember at the beginning we said capacitors store charges. So the energy stored in the capacitor or in the circuit, that's the C, energy stored equals 1 over 2 the effective capacitance multiplied by the square of the voltage that we have there. half CV squared. That's the energy stored. The energy stored will now be 1 over 2 multiplied by the effective capacitance, which is 30 times 10 raised to the power minus 6, multiplied by the square of the voltage that we have here, that's 100. So mathematically, when you do this, this is 15 times 10 raised to the power minus 6 multiplied by 100. And you have this as, if you multiply 100 by 15, that is 1500 multiplied by 10 raised to the power minus 6. And that can be said to be 1.5 times 10 raised to the power minus 3. Energy stored is always in joule. Energy stored is in joules. So that is the solution to the problem given here above, step by step. If you enjoyed this, don't forget to subscribe to our channel. Click on the like button for more interesting educational videos like this.